Today's objective is rational numbers. What we're really doing with the rational numbers are converting decimals to fractions and fractions to decimals. Now, 90% of this is review, so there's a lot of writing, but most of it's review, okay? So you don't have to write it all down. A decimal, for example, 0.5, or a fraction, for example, 1/2, represents a piece of one, a piece of a whole, all right? It's less than one. If you have 50 cents, which this looks almost like 50 cents, that's less than $1. Okay, a mixed number, 2.5, or 2 5/10, or -2 1/2, contains an integer and a fraction or a decimal. Okay, so that's something that you need to really realize is if when people talk about decimals, it's less than 1, and when we talk about fractions, they are less than 1. But people say decimals and fractions when they meet a number that has a decimal or fraction, but technically they're less than 1. Okay, so for review, to change a decimal to a fraction, 3 steps. Number 1, read it aloud. Number 2, write down what you said. Number 3, reduce the fraction. So read it, write it, reduce it. Number 1, it's 0.6, but how do we read that in decimals? 6/10. Wow, 6/10. Can you write that down as a fraction? 6/10? I bet you can. And can we reduce both numerator and denominator? Yes, by 2. And when we do that, we get 3/5. Here's our second decimal, 0.35. But read that as a decimal, it's 35 hundredths. If I say 35 hundredths, can you write that down? 35 over 100. And those can both be divided by 5, the numerator and the denominator, so you would get 7/20. Okay? If you have problems reading it, if the tenths and hundredths and thousandths isn't something that you learned that well, you can think about the number of places after the decimal point, because it equals the number of zeros in the denominator of the fraction. So look over here. 6/10, 0.6. How many places are after the decimal point? 1. So there's 1 0 in your denominator, and then you would reduce that. 35 hundredths, how many places after the decimal point? 2. So there's 2 zeros in the denominator. There's always a 1 because it's always over 10 or 100, and then you would reduce that, okay? But read it, write it, reduce it. That's the best thing to do. All right, but what about repeating decimals? We have repeating decimals. Well, instead of making the denominator with 1 0, 2 zeros, 3 zeros, 10, 100, 1,000, etc., you use a 9 instead of the 10. So it would be 9, or 2 9s, or 3 9s, 999, 999 for decimals that repeat. Okay? It's kind of cool. Instead of counting the number and putting zeros, now you count the number and put 9s. The number of 9s in the denominator equals the number of digits that repeat. And there is an asterisk to this, and I'll tell you in just a minute. But for now, let's do the math, okay? So, repeating decimal to fraction. Count or look at the number that repeat. Number 2, write it over that many 9s. Number 3, reduce it. If you divide by 3, it'll always work. So, for our first example, we have 0.3 repeating. And this line means that it would be 0.3333333 forever. Okay, I got tired of saying 3s. So how many, let's look at our 1, 2, 3. How many digits repeat? 1. There's 1 digit that repeats, the 3. And so you put that over 1, 9. Okay? 3 goes in the numerator and 9 goes in the denominator. Just like when we were doing our non-repeating decimals, what was the decimal went in the numerator, and then 10 or 100 or 1,000 went in the denominator. Okay, divide by 3, the numerator and the denominator, and we get 1/3. Here's another example, 0.6 repeating. Now you should know that 0.3 and 1/3 are the same thing. Well, 0.6 repeating is the same thing as 2/3, and here's why. There's one digit that repeats, it's the 6, so you write the 6 over 1 9, reduce, divide by 3 over 3, and there's our 2/3. What if we have more than one digit repeats? What if we have 0.27 repeating? That would be, let me write this, 0.27272727, and it goes on forever, okay? But you don't need to do that. You just write the digits that repeat and put the line over the top. So here there are 2 digits that repeat, so I write the 27 in the numerator and 2 9s in the denominator. Okay, but I can reduce this. When I divide by 3, I get 9 over 33. I can reduce that again. So I divide by 3 again and get 3 over 11. All right, so you can also divide this by 9. Okay, you can divide by the biggest number. That's the most efficient. But dividing by 3 will always work. That's why I said divide by 3. All right, here's another example. 0.51 repeating. All right, how many digits repeat? 2, so we put 2 9s in the denominator, the 51 goes in the numerator, divide by 3, and it becomes 17/33s, which I cannot reduce anymore. All right, here's your asterisk, okay? This only works, putting the 9s in the denominator, when all of the digits repeat, okay? The bar has to go over everything that's after the decimal point. Other common repeating decimals you can memorize or divide, but memorizing is easier. All right, one more page. Now let's talk about fractions to decimals. You probably remember to change a fraction to decimal, you divide, okay? But it's easier if you just learn the common ones. Now where kids make mistakes in dividing is they set up their problem wrong. If you're dividing, if you have 1/4, the 1 goes in the inside. The numerator goes on the inside. If you're dividing and you get a whole number, you've made a mistake. You cannot change. This is 1/4. You can't change a quarter into like $7. Doesn't work. If it does, come see me, okay? So the 1 goes in the inside, the 4 goes on the outside. If I'm looking at this, does 1 go into 4? No. So I have to put up a decimal. Say no and write a 0. Put up a decimal point, add a 0. Does 4 go into 8? Twice. Put up the 2. 2 times 4 is 8. Subtract. I get 0. Does 2 go into 0? Sorry. Does 4 go into 2? Nope. So I put another 0, because once I'm in decimal land, I can add as many zeros as I want. 4 goes into 25 times, I'm done. 1/4 equals 0.25. How about 5/8? 5 goes on the inside. 8 goes on the outside. Does 8 go into 5? Nope. Put up a 0 and a decimal point, add a 0 to your 5 and make it 50. Does 8 go into 50? Yep. 6 times. 6 times 8 is 48. Subtract. We get 2. Add another 0. 6 goes into 20 twice. 2 times 8 is 16. Subtract. Get a 4. Add another 0. 8 goes into 45 times. It ends. Okay? These are problems where I'm not going to say, give me a remainder. All right? We are doing decimals. So they will terminate, which means end, or they will repeat. All right, how about 1/6? Put with the 1 on the inside, 6 on the outside. Does 6 go into 1? Nope. Put up a 0, a decimal point, add a 0, so now it's 6 into 10. 6 goes into 10 once. Putting down the 6, subtract, we get 4, add a 0. 6 goes into 46 times. Subtract. Oh my gosh, we have another 4. Okay, so if I put another 0 on and make it 40, 6 goes into 40, 6 times. Subtract. Oh my gosh. This is a repeating decimal, okay? But you notice all that repeats is the 6. You don't write the line over the 1. It's not 161616. So 1/6 equals 0.16 repeating, okay? Let's say you had the problem 6/5. Notice all of these have improper fractions. 6/5 is an improper fraction because the numerator is larger than the denominator. Well, I can do the same thing. Let's ignore this for a minute. I can put the 6 on the inside, divide by 5. 5 goes into 6 once. 1 times 5 is 5. Subtract, we get 1. 5 does not go into 1, so I have to put up my decimal point, put a 0. Now 5 goes into 10 twice. And we get, it zeroes out, so we get that 6/5 equals 1.2, or 1 2/10. However, you can just convert, you can say 6/5 equals 1 1/5, and then just convert the fractional piece. It's easier to do it that way, okay? So 1/5, we do it just like we did these problems up here. 1 goes on the inside, 5 goes on the outside. 5 go into 1, nope, put up a 0, put a decimal point, put a 0 on the inside. 5 goes into 10 twice, and you're done. Look how much smaller this step was than this step. So 6/5 equals 1 1/5, which equals 1.2. We did the same work. Just don't forget your whole number, okay, after you've changed it from improper to mixed, or you'll get it wrong. All right. Here are some common fraction and decimal conversions that it would help you to memorize. Okay. 1/2 is 0.5. 1/4, 0.25. These you should write down, and you're going to have to pause it. Okay. 3/4, 0.75, and then 1/3, 0.3 repeating. 2/3, 0.6 repeating. Those are the fourths, the halves, the fourths, and the thirds. Okay, because 2/4 is the same as 1/2. How about the eighths? 1/8 is half of 1/4. If you added a 0 onto this, half of 250 is 125. Okay, so 1/8 is 0.125. 3/8 is 0.375. 5/8 is 0.625. 7/8 is 0.875. If you add your 0.125 to your 1/4, you get 3/8. If you add your 0.175 to your 1/2, you get the 5/8. And if you add your 0.125 to your 3/4, you get your 7/8. Pretty cool, huh? All right, the fifths you probably already know. 1/5, 0.2, 2/5, 0.4, 3/5, 0.6, 4/5, 0.8. Notice it just increases by 0.2 each time. And then the two repeatings, that one we did and the other one I want you to learn besides the thirds, are the sixths. Okay? 1/6 equals 0.16 repeating. That's my favorite because it's the same digits. Okay? Now 2/6 is the same as 1/3, which we've done. 3/6 is the same as 1/2. 4/6 is the same as 2/3. So the only other sixth you need to learn is 5/6, which is 0.83 repeating. What? I know, I don't know, just memorize that one. Okay, so in your conversions, you need to remember that 1/2 is the same as 2/4, which is the same as 3/6, which is the same as 4/8. Anytime the numerator is half of the denominator, it's 1/2. 1/4 is also the same as 2/8. 3/4 is the same as 6/8. Okay, we just reduced them. That's why I didn't make you find the 2/4, the 4. I'm sorry. That's why I didn't make you find the 2/8, 4/8, 6/8, or the 2/4. Okay, because they reduce them. They're all the same. And the same with the thirds. 1/3 is the same as 2/6, which is the same as 3/9, and 2/3 is the same as 4/6, which is the same as 6/9. And the nice thing, I didn't write this down, but the nice thing about ninths, anytime you have repeating, if you have, I'll put that now, if you have 0.1 repeating, it looks like a 10, let me fix that. 0.1 repeating, it's just 1/9. Okay, so we can talk about it more in class. If you want to see the math on why the ninth works, I can show you the math. Okay, come into class. Bye.